In the 21st Minitab tutorial, we accompany the ultrasonic testing laboratory of Smartboard Company. In this department, the manufactured skateboard axles are subjected to ultrasonic testing to ensure that no undesirable cavities have formed in the axle material during axle production. In materials science, cavities are microscopically small, material-free areas which above a certain size can lead to a weakening of the material and thus to premature axle breakage even under the slightest stress. The ultrasonic testing used by Smartboard Company for this axle test is one of the classic non-destructive acoustic testing methods in materials testing, and is based on the acoustic principle that sound waves are reflected to different degrees in different material environments. Depending on the size of the cavity in the axis material, these sound waves are then reflected back to the ultrasonic probe to varying degrees. The size and position of the cavity in micrometers is calculated from the time it takes for the emitted ultrasonic echo to be reflected back to the probe. The focus of this Minitab tutorial is to evaluate the ultrasonic testing device with regard to the measurement system criteria of linearity and stability, in order to detect any systematic measurement deviations. Specifically, we will learn how the stability and linearity parameters can be used to find out how accurately the ultrasonic device can measure over the entire measuring range. For this purpose, the ultrasonic testing team will randomly select 10 representative skateboard axles, based on the recommendations of the AIAG standard regulations, and subject them to ultrasonic testing to determine the size of any cavities in the axle material. Before we get into the stability and linearity analysis, we will first get to know the useful function of variable counting, as part of data management. We will then apply appropriate hypothesis tests to identify significant anomalies in terms of linearity and stability. We will use the useful graphic scatter plot to give us a visual impression of the trends and tendencies with regard to linearity and stability, so that we can make a statement about the existing measurement system stability and linearity on the basis of the corresponding quality criteria and the regression equation. Finally, we will carry out an optimization of the measurement system based on our analysis results, and then reassess whether the implemented optimization measures have improved our measurement system stability and linearity.